Geometry, the wonderful world of geometry. Here we go. We're doing surface area. So it's just what it says. It's the area of all the surfaces. All right, we're going to find the area of each face of a three-dimensional figure. Today we're focusing on prisms. We're going to find the area of each face, and then we're just going to add it up. It may be easier when we're dealing with rectangular prisms only, not triangular prisms, not pyramids, just rectangular prisms. It may be easiest to use this formula here. All right, so there's a special formula, but it does not work for any other type of three-dimensional figure. It only works for rectangular prisms. So what we need to do is just rewind just really quickly to give you a little bit of insight as to where this formula comes from, and also some idea of this concept of a net. So if we were to slice along these edges and open this shape up so we could lay it flat, that would be the net of the shape. And we'll quickly go to another website. I linked it so you guys could also check it out. This is a pretty cool website. It's clicked on prisms. Read through about what prisms are as a review. The big thing is congruent bases, congruent polygon bases. So, like for instance, this one has a hexagon on the top and a hexagon on the bottom, and then rectangles that wrap around. So they have hexagonal bases, two hexagonal bases, and then the lateral faces are rectangles. All right, here's a pentagonal prism. So pentagon on top and bottom, and rectangles that wrap around. Those rectangles are the lateral faces. That's what a prism is. Now we can explore and play with prisms. This here is a triangular prism. Now watch this. If we press play here, it'll fold it up and make that triangular prism and unfold. That is a net. All right, and why I want to show you that is because it shows you how this lesson we're doing today kind of relates to a lesson we did previously, which was area of composite figures. If I pause it right here, this flattened out shape is just a two-dimensional composite shape, right? It's a complicated shape made up of smaller, simpler shapes. All right, or a polygon. So we could find the area of that rectangle, the area of that rectangle, the area of that rectangle, then find the area of this triangle, and add them up. And we'd get the area of the whole thing, the area of the whole composite shape, as long as we find each individual one and add them up. Then we wrap it up and pause it right there. And now that added area, when it's wrapped up, we call it the surface area, because it's the area of all the surfaces of this polygon. So that is what we're talking about today. Let's look at a rectangular prism. If I fold this net up, it should turn into a rectangular prism. Let's watch. Ta-da! All right. So if I pause it here, here's the net. If I find the area of each of these 6 surfaces and add them up, I get the area of this whole shape, which is the area of, or what we call the surface area of, this three-dimensional shape called a rectangular prism. All right, so we're finding the area of each face and then we're adding it up. Just for fun, let's look at this one. So cool. Fold. That is cool. This is such a fun website. All right, and you can click on the octagonal prism there yourselves. All right, let's get back to our notes. Okay, you should have a textbook out. You should be writing in things to help you make sense of all this. All right, now I wanted to talk about how this formula came about for a rectangular prism. Why do you think there's a 2 here, a 2 here, and a 2 here? Might be easier to see if we go back to that website and go back to the rectangular prism. All right. If we look at this and we open it up, you can see that, oops, you can see that each different rectangle has a matching buddy. So for instance, this one and this guy are identical. So if you find the area of this, which you do like length times width, all right, if you get that area, you can just double it, and then you'll have the area of both of these two. Same thing for this shape and this shape. All right, if you do the length and width and then just double it, you'll get the area for both of those. And then this one and this one down here, same thing. All right, so if you can see that, then that will help you understand where this formula comes from and maybe be able to use it a little bit more efficiently. All right, here's a good definition of surface area. The sum of the areas of all the surfaces or faces of a three-dimensional figure is known as the surface area. All right, we just talked about nets, so I think we're headed in the right direction. Now, what we want to do here, for example 1, they're going to have us use the formula. The formula here. You can just kind of look at each face. There's 6 faces, and find the area. So if I'm looking at this side face here, all right, if I'm looking there, all right, I could do 7 times 13, and that's the area of that rectangle, and then it's identical to this side face over here, so I just times it by 2, all right? And then you could do the top and bottom, this one and this one, and you can see that their dimensions are 9 by 7, and since there's 2, we'll double it. Anybody see the last couple sides? Well, we have the front. It's hard to check these off, but we'll do the front and then the back. I don't know if you can see that. What are the dimensions of this front here? It looks like 9 across there, and then the height would be 13. So that's 9 times 13 and times 2, because there's 2 of them. All right, so this is basically the same. You can see the 2's, and it's basically the same as this formula. So this formula might just be a little bit easier instead of going through and checking off everything. But I want you to see where it comes from. Now, let's give you a strategy to use the formula. If you're dead set on using that formula, then okay, but you need this to help you. All right. First thing, if you're going to use the formula for rectangular prisms, is that you label each of the dimensions. So there's 3 numbers. They give you 3 numbers here for this rectangular prism. One's going to be the length, one's going to be the width, one's going to be the height, but it's easy to get them kind of mixed up. So what we'll do is we'll write an L for that one. We'll write, let's see, the height is 13, so we'll write a height there, and then we'll call 7 the width. It does not really matter which one is which. You just need to make sure you label L, W, and H for the 3 dimensions of the rectangular prism. Now, once you label them, it's pretty easy just to plug everything in. So wherever there's an L, you put the 9, and wherever there's an H, you're going to put a 13, where the L, 9, W is 7, H, 13, W, 7. Notice how in the formula, if to memorize this, all you have to do is make sure that the L is paired with the H and the L's paired with the W, and then the other pairing that hasn't been made yet is the H and the W. Okay, so each dimension has to be paired with the other 2 dimensions. They can't be like doubled up at all. All right, so there you go. Yeah, then you simplify. Remember to do multiplication, all the multiplication first, then add up the results, and you get your surface area. Okay, try these ones out yourself. All right, make sure you're showing your work. Use this space over here or the space under here to show the work beautifully, just like they do up here. Write the formula, substitute in, show your work, put the answer, label it. All right, and don't forget to label these dimensions. So that would be L, that would be W, and that would be the H. Okay, so make sure you do that each time and you should be on the right track. Otherwise, the rest of it's just plugging it in and getting the answers. All right, pause, try it, and then unpause to see the answers. All right, so the answers are 216 meters squared and 729 meters squared, millimeters squared. Why is it squared in this case? It's because we're doing area, which is a two-dimensional measurement. All right, it's just measuring on a flat surface how many squares could fit there of a certain unit. So these should always be area. If it says area, it's going to be square units. Okay, let's go to the next page. Oh, strike that. Let's do the work for part A. All right, I'm going to do that over on the side here where I can actually write. All right, so let's write the formula. So surface area of a rectangular prism is going to be 2LH plus 2LW plus 2HW. We have, let's see, my L over here. My L over here is 10. So 2 times 10. My height that I labeled is 6 plus 2L was 10 times W, which is going to be 3, plus 2 times the H is 6, the W is 3, and now I'm going to do my work here. So we got 60 times 2, that's going to give us 120. I got 60 plus, let's see, that's 12 times 3 is 36. All right, and then I just have to add these ones up, and that comes to 180. So 216. Am I right? Yeah, 216. All right, so there's the work here, and I have to put my square units. All right, I'm just going to use the same formula here. There we go. For the next one. So you can check and see if your work is correct. Oh, it's a cube. We have 2 times 11 times 11 plus 2 times 11 times 11 plus 2 times 11 times 11. I did not label over here, naughty, but I know that they're all the same, so I'm just going to do this. So 11 times 11 is 121, and double that. So 121 doubled is going to be 242. So each of these is 242. And then we're going to add those up. We're going to get 700. Let's see. 726, I believe. Oh, it's already up there. Okay, so anyway, there's the work. You can check if you got it right or wrong and check to see where you might have made your mistakes. All right, moving on. Now, we're not going to focus in too much on this problem. I think it's just a little bit too challenging. You can read it through if you want and see if you can figure it out yourself. The idea here, though, is that it's talking about painting something or covering a surface. Covering a surface is typically an area idea, so that's the big thing that you have to grasp from here. If a problem, or if you're wanting to paint your bedroom and you need to know how many gallons of your favorite color, that sparkly light green that you want to decorate your room so you can feel like a princess, all right, is you're going to need to calculate, well, how much area is on my walls so that I can get the right amount of paint. That's what this problem is about paint, but the idea is, are you covering a flat surface? If you're covering a flat surface with something, that's going to be an area situation. So you're going to have to use formulas and whatnot, all your understanding of area to help you solve that real world problem. So in this case, the largest corrugated cardboard box ever constructed measured about 23 feet long, 9 feet high, and 8 feet wide. Would 950 square feet of paper be enough to cover the box? See the word cover there? Cover. that's your big indicator that, oh, this is an area idea. Oh, how would we go about doing this? I'm going to use my same formula here. And the issue is they don't have a picture, so it's a little bit different than other ones we've done, but they do tell us that the length is 23, the height is 9, and the width is 8. So then we can just plug it in. All right, we can just plug these in, replace the L with 23. The H is 9 plus 23 times 8 plus 2 times 9 times 9 times 8, right? And then you can calculate it. And it looks like it comes to, what do they say it comes to? 926, the area of the box. So when we add all those up, it comes to 926 feet squared. And they said they had, what? feet of paper, 950 square feet of paper. Don't know where you come up with that much paper, but looks like the paper we need to cover it is less than the paper we have. So we will have enough to cover it. All right. Now we're going to move on to surface area of triangular prisms. And there's no formula for this. I mean, you could make a formula, I guess, but I think it's easier at this point to just treat it as a composite figure, as a two-dimensional composite figure where you're just finding each area, the area of each face, and then you're going to add it up. So it says it right here. You might want to underline this. To find the surface area of a triangular prism, it is more efficient to find the area of each face and calculate the sum, that means add it up, of all the faces rather than use a formula. So we're going to, I'll ask you, how would I find the area of a triangle? Well, let's write it down. Write down in your notes the formula for the area of a triangle. Area equals 1/2 base times height. And remember that the base and height always meet at a right angle. Let's say I have a triangle that looks like this with the right angle up there. And let's say I give you this 3, 4, and 5. Well, which dimensions are you going to use to find the area? All right, it's tricky because they give you an extra dimension. Which ones? Well, we're going to cross off this 5. Why? Because it doesn't meet any of the other sides at a right angle. So these two would be your base and height. All right, so that problem came up a bunch with our volume situation. So area of a triangle, if we're looking for area for a triangle, we have to remember those little things. And then area of a rectangle is just going to be base times height. All right, for a rectangle. So write that down in your notes because you'll just need those two formulas for this lesson. All right, so then all we're going to do is for this, we're going to multiply the base times height times 1/2. And that gives the area of that, find the area of that, find the area of these three, add them all up, boom, you're good to go. Now, they drew them out for you, which is nice and makes it a lot easier, but you're going to be stuck with a drawing of a three-dimensional shape, and you're going to have to kind of unwrap it all by yourselves with your brain. All right, so that's going to be a very challenging part of this. Okay, how much cardboard is used to create the shipping container? So cardboard is kind of like an outer wrapping. When we're talking about outer wrapping, that should indicate in your head, oh, I'm doing surface area. So find the area of the surfaces and add them up. Let's see if we can do it like they do it over here, okay? I'm going to take the answer off there. And let's see, find the area of each face and add. So it looks like the area of each triangle, they did 1/2 times 4 times 3. So, okay, I see. Let's see. So they looked at this and found the height because they meet at a right angle. Found that, and then, okay, they get 6 there. But Oh, see, I would have doubled that 6, but it looks like they added up the 6 and the 6 for the triangle in the front and the triangle in the back. So there's different ways that you can definitely do this. You just have to make sure you account for all the faces. All right. The area of two of the rectangles is 14 by 3.6. Now, how'd they get that? Okay, I'm going to do it in a different color here. It looks like they went this and this. Wow, that's hard to see. Is that kind of back rectangle, and then also it's the same as the front rectangle because you can see back here that's labeled 3.6. All right, now we just have to get the bottom rectangle, which you can't really see, but we see that one dimension is 4, and then it's kind of like on the bottom here. You can't really see it, but 4 by, what's that? 14, the full length of this, or full height of this prism here, okay? So that's kind of confusing, but take your time to think it through and visualize it or unwrap it in your head and then draw all the dimensions in. So let's try this next one. Now, I like to actually draw them out. So I'm going to draw out my two triangles, the front and back, and then I have the bottom rectangle. I'll call this bottom. And left and right, maybe? How about that? Left rectangle and the right rectangle. All right, now I'm going to look at them individually and see if I can find their area. So area equals 1/2 base times height. Area equals, okay, so over in the picture, I got a base here of this triangle of 3. And then the height goes up at a right angle of 2. So that's going to be 1/2 times 3 times 2, which gives me 3. So that one has an area of 3. Is this the same exact triangle? Yes, it is. Now, don't get confused with this 2.5. That's not going to help you with this back triangle, all right? Remember, we're just focusing on what meets at a right angle for that triangle, which is that 3 and that 2 centimeters. So that area is also going to be 3. It's identical to this other one. These two are the same, all right? Now we're going to focus on the bottom here. What are the dimensions of that guy? All right, well, it looks like it has a dimension of 3 and a dimension of 4. So area equals base times height. That's going to give us 3 times 4, which 12. All right, now we got I'm going to erase that. No, I'm not, I guess. I'm going to clear. Yes, please. All right. Anyway, so now we're going to talk about the left rectangle, which I'm having trouble here. Left rectangle, it won't let me draw anymore. It's glitched out. So anyway, is way over there. So, let's see. How am I going to find those dimensions? Well, I see these little tick marks. What in the world does that mean? Those mean that those are congruent. They're the same. So if that is the same as that, what is that? What is this one right here? Well, since it's the same, going in the same direction as this 2.5, that means that this front one's 2.5. Since it has a tick mark, that means this is 2.5. So then that's at least one of the dimensions. So that's 2.5 over there. And I'm going to draw over here now. 2.5 is right there, and that length on the bottom is 4. So that's going to be area equals base times height. So 2.5 times 4, which gives us 10. And then is the right side the exact same? Well, yeah, because that has that tick mark. So that's 2.5 by 4. So that's going to also have an area of 10. Now, I've got 1 area, 2 area, 3 areas, 4 areas, 5 areas. Are there 5 faces to the shape? Yes. So let's add them up. 3 plus 3 plus 12 plus 10 plus 10, and that gives me my grand total 10, 20, 32. 32 plus 6 is 38 centimeters squared. And make sure we're right. Okay, 38. Okay, so there's our lesson. We have to, there's definitely challenging parts. Sometimes finding the dimensions can be pretty tricky, but the general idea is pretty simple. The general idea is find the area of all the faces and add them up. All right, good luck. And I hope it's not too confusing or challenging, but that you're able to work through it and figure it out.